Hi everyone, welcome back to the series. So here we're going to cover two main things. One is testing, and the other one is try expect, just a way to test. So what I did for this was I made a tic-tac-toe game just to mess around. We don't really call it tic-tac-toe in England, we call it noughts and crosses, but for the Americans out there, and tic-tac-toe, it's quite an easy project really, but there aren't too many. The main problem is things like maybe checking winners or stuff like this, and then also getting console input is probably the most annoying thing about Zig. Let me just get to the main function. I have too many functions here. So main, you just print out. I'll just show you. First, I'll show you how it looks. It's a very simple game. So it prints tic-tac-toe commands, and we have the commands like 1 to 9 selects the square, quit will quit. So it quits. And open this again. Right. So it's X to move, and we pick a square, so let's go in 1, something like this. And then it's O to go, so let's go 5. And then there's X to go, let's go 3. Now we're forced to go 2. And then he is forced to go 8. Then we can go maybe, let's go 7. For X, no, we can go 4. Let's go 4. And we can force him to go to 6. Then you are forced to go 9, and then it's a draw. 7, and it says draw. Then it loads the game again. So draw, loads the game again. If I just show you a win quickly, just to show it does work. Let's go 5, let's go 2, let's go 6. Also, if you put it the wrong, say if I go 6, it says square occupied. 3, x1, and then it loads again. So it does work. Very simple game. It's not that hard. So here, just print commands. It's just simply just going to print the commands. Where the hell is that? So yeah, it just prints the commands, and it's pretty simple, honestly. Print the board. So this was a bit annoying, actually, to get this to work. So I'm using int from enum, which is always a really fun thing to do. I have a, let me just open the constants. So I have a file here for just the load of constants that I made, and I'm just linking that at the top using con. So everything that's con is linking to constants, which basically just has like 1, 2, 3, 4 for the commands, some square choices, just for a list of arrays, and then just a few constants basically. All right, so print board. Here we're basically creating I believe this is just a character. Or this is just one character. We have con piece characters, which links to piece characters, which is just like space X or O. Board, which is this array of U2. I used U2 because it's either 0, 1, 2, so you only need, 2 bits to use all those. And it's just set to empty at first. And we use border enums.squares 1. So basically whatever's at the board at 1, so enum squares, so con squares is an enum here, which is 1, 2, 3, 4, like this. So I'm basically just like, I could use a constant. Maybe it's a lot easier than writing int from enum, but anyway. So basically, what is the value at 1? What is the value at 2? What's the value at 3? Just get the value of all these numbers and then place them on these lines. So square 1 is here. The reason why I've separated these into values is because if you put this in here, it's unreadable as hell. So I separated them. Then I just print the lines, made them slices, and then just print if X to play, then put an X, if O to play, then put an O. And then this is basically the template I used, what I want to make. That's printing the board. So then console loop. So we create a console loop, go down to here. Where's the console loop? Here's the console loop. So I'm using the FBA, fixed buffer allocator. The problem with using an FBA is that if the user goes over 100, it will segfault. And I will show that right now. It will segfault if I go over 100. I believe you should use like the page allocator if you don't want this to happen. So if I just spam 100 times, hit enter, segfault, segmentation fault. So if you don't want that to happen, then you can use the page allocator, but the page allocator is a bit slow. I don't really care. It's just a tic-tac-toe game, so I don't really care. The user could just get a segfault if they want. All right, so here, yeah, we segfault, and then we We create it, so we only create it once because we don't want to create it more than once. We just want to, yeah, use it in the while loop and not create it each time. That's slow. So choose a move, just print that. User input equals STD reading until delimiter, sorry. So when we find a new line character, we stop and we go to 100. And if not, we invalid input, but most of the time it just seg faults anyway. If you get to this point, we defer it each time. I'm not sure if you need to defer it each time, but it doesn't matter. We defer it so it will basically go here. And then so we process, we go should quit equals process input. So we go to process input. So we put in the slice. We get a slice from the user. And then we have, so that maybe there's a way to, I think there was like someone recommended std.mem.equal to test if two slices are the same. I couldn't get it to work. I kept getting errors, so I just made my own. Slices are the same in a bool. So I just want to test if I was just doing print just to test things. I just want to test, is the slice the same? First I couldn't get it to work just because so the user puts in will have a new line character. You need to remove it. So here I put first length -1. So basically the length, and we compare the length. So first length is the length of the first, and then it just be the length of the slices. We compare them. They're not the same. They can't be the same. Don't bother looping. It's just a waste of time if you're looping. And anyway, 0 to first length, and then first index. Sorry, yeah, first the length the same, so you can go to first length. And then we just say if it's not, then we turn false, and at the end we return true. So they're the same. So basically what I'm saying here is con.quit. Here's all the commands. So if it's any of these commands, are they the same? Here I made a for loop to not write this. Like slices are the same. I put them in choices. Sorry, square choices. Yeah, so I made an array of const u8s, which is just linking to these. So I looped through that. Made this a u4 because that's the only range it goes up to. All right, and then if we find a move, so say for example the user types in 1. All right, so if it's 1, and we make a move and we put in the found index, and the found index is a u4, which we add each time, and then we make a move, which I for the life of me can't find. There it is. Okay, make move. Okay. So we have if board con.empty print square occupied. Oh, basically, if it's not empty, then it's occupied. Leave it. If it's X to play, then you set that to X. Then you flip it to Y to play. You print the board, check the winner, and then you do the exact same thing, but you make it O and make it true. And then to check the winner, I used bitboards. Don't know if anybody know what bitboards are, but they're basically a way of so you have zeros and ones in a number, and what we do is we create a 9-bit number, and you can say, is there a 1 here, 0 here, 1 here, 0 here, 1 here, 0 here. You can use this to check things in a very efficient way. So here I loop through all the squares, and I say if it's empty, then set a bit on the empty bitboard. If it's O, then set a bit on the O bitboard. If it's X, then set a bit on the X bitboard. And bit index was a bit annoying to do in Zig because shifting bits is just strict as hell, so I just basically just doubled it. U9 I just doubled it each time. That's basically the same thing as 1, 2, 4, 8 is how bits work. If it's X to play, then we check if is 1 by simply looping through this array, win check, which is just a link of these, which is just checking if these bits are set. So if it's like this bit is set, and if we go through all the O positions, the O board, and we set the bit board like that, and they're the same, we AND them together, meaning like if these are set and these are set, then they'll be the same. That's basically what AND does. And if they're the same, they won. It's just a quicker way to check if you're a winner, just to use a bitboard. And then the same with X. If there's X in a row, we're just checking if there's stuff in a row. And if empty bitboard is 0, that means that all the places are taken, and also no one's won because we haven't returned. So no one's won, no spaces are free, it's a draw. And when we go 01, we simply just say 01 and reset the board and then print it. And then X1, reset the board and print it, draw, and then put draw, and then reset and print it. That's pretty much it. That's basically the program. So I wanted to test this, and it's quite annoying. So you could, in theory, just test it by doing stuff here and then changing it. But say if you want to keep the program the same, you can just write a test. So I created an enum just for a result quickly, and I have a test setting positions. So I created a way to set a position just because I was lazy. So this is a way to set a position. So I'm setting white winning. So it's like X, 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 O, O. The rest is empty. So X should win because there's a 3 in a row at the top. And we're checking result should be a win. And we have this std testing.expect, which is probably the simplest function in the world. If I show you on the std in the standard library, I go up here and type in expect. std testing.expect, the simplest function you'll ever see in your life. fn expect, if not okay, return error. So if okay, return error, because it's a bool. It just takes in a bool. It basically, if the bool is false, return an error. That's basically all this function does. You could, in theory, write that yourself if you wanted to. But here I'm just checking. So but to call a test, so what you do is you just write test here. And then this will run. And we're basically checking. I made a specific function for the testing just because this test, well, the other test checks if it's O or X to play. I want them both to test. I don't care about X or O to play. Anyway, so to run a test. So what we do is we go zig test, whatever the name of the thing is. So this would be tic tac toe.zig. And that runs the test and basically just sees if it works. So here we have XXX, X to play, and so X should win, and it passed. Here there should be nothing. I believe that, yeah, it should be here, result, none, it's correct. Here there should be X win, X win is correct. And you see at the bottom, all tests passed. So it's just a quick way. I could put in like a load of these combinations. This is an easy way to test if a function works. So you basically just write test, and then the name of it, and then I normally use unreachable. Unreachable will just like crash the test. It will fail the test. Basically, the test will be successful unless there's an error, and that's how it works. So tests are very useful. They're very useful for finding things because you don't need to like rearrange your entire program just to test stuff. You could just write a test, and then you don't need to use it. If you want to run the program, you just go, instead of tests, just go run. It's like you separate the test from the run. And see, I can still run it. I can run them entirely separately. So tests are very, very useful. I definitely recommend using them. But that's all for this video. Let me know if you have any questions, and see you guys next time.